and today we are going to discuss the topic of vectors. You all are familiar with vectors and you know what is a vector quantity, what is not a vector quantity. Something which is not a vector quantity can be termed as scalar, and sometimes you all must be knowing it is known as a tensor. So we will discuss what is a vector and how do we represent the vector, what are the laws related to the vectors, what are the number of components possible of a vector, about a direction, any direction, x, y or z direction, and how to represent a vector, like, and what are the laws related to the addition of vectors, like we have parallelogram law, we have triangle law, polygon law, etc. These are all applicable to these vectors, and apart from this we will also discuss what is the component of a vector taken on another vector, that is dot product of the vector. We will discuss component of vector with respect to another vector, and we will also be discussing the cross product, what are the physical meanings of these products, and the scalar triple product, etc., the condition for two vectors to be orthogonal, parallel, etc. These things we will be discussing here. So first of all, let us discuss what is a vector. As you all know that a physical quantity which is having both magnitude and direction is called a vector. Magnitude plus direction. So this is a vector, and the example for this is force. Suppose you have a body which is kept here, and what you do is tie a string to this body and pull it in this direction. This is making an angle of, say, theta with the horizontal direction. You are applying the force F. So if you simply say that I am applying the force F, it does not mean anything. You are applying the force. So what is the force F? It must be having a magnitude, say 20 Newton. But in which direction, that you have to specify. So direction is theta, in the direction parallel to the horizontal. So the force is having the magnitude F and the direction as well. So this is termed as a vector. Similarly, we have the velocity. What is velocity? If you move from this point to this point, A to B, so you have traveled a distance s in a time t. So I can say that the speed of the body which is moving, or the person, A to B, is distance traveled divided by time, so s by t. What is velocity? Velocity is same here in this case, s by t, but velocity is having a direction. If it is moving in this direction, this is west, this is east, so I must say west to east. So velocity is having direction along with the magnitude, speed is having only the magnitude. Now suppose a person comes back on reaching B, it comes back from B to A. So in that case, velocity, we also call this as average velocity. This is equal to total displacement upon time, total time. So what is the displacement? In moving from A to B and B to A, displacement is 0, because displacement is a vector. It is also termed as shortest distance moved by a body, because if a body is moving, say, along a curved path from starting point to end point, so the distance moved is along this. But if you say that the shortest possible path is this, then displacement is along this path from A to B. So it means that displacement is the shortest path, but it should have any direction. So that's why we call that this is a vector, whereas distance is not a vector. Similarly, we have acceleration is a vector. So these are some quantities which are termed as vector, and the quantity scalar, which is having only magnitude and no direction. So distance, speed, pressure, etc., they are termed as the scalar quantities. Now, one thing you should know that to qualify as a vector, the physical quantity which is termed as a vector must follow or satisfy the rule of vector addition, like parallelogram law, must satisfy the parallelogram law, etc. Suppose we have a rigid body. It is having rotation about this axis. So rotation is having magnitude, the angular velocity, it is having magnitude, it is also having a direction. If you apply the right rule, suppose it is rotating in this direction, so my fingers are curled in the direction of rotation, thumb is telling the direction of rotation vector. So this is the direction of rotation vector. So it is having direction and magnitude both, but this is the, I'm talking about the finite vector, finite rotation, like completing a whole circle. So this is not a vector, but the rotation of small magnitude is a vector. Because two rotations, like the distance moved in two rotations, or any other quantity related to rotation in two consecutive rotation, cannot be summed up as a vector. As far as this small rotation is concerned, so any physical quantity related to that can be summed up by using the laws of vector addition, like the parallelogram law. So if a body is rigid body is having finite number of rotation, in that case it cannot be, the quantity cannot be termed as a vector. Then we have some quantities like area. Area can be termed up both as a vector and a scalar. Sometimes we call it a vector and sometimes we call it a scalar. So we use it according to our specific requirement: area, current density, current per unit area, and dipole moment. They are termed as vectors as per requirement. Now this quantity, this can be used both as a vector and a scalar. Can be used both ways, vector and a scalar. So some quantities, like we have moment of inertia. What is moment of inertia? I will not discuss it here. You all must be knowing, we will be discussing this in the chapter related to moment of inertia. So moment of inertia is not a vector. Then under what category does it fall? So it is neither a vector, but it is not a scalar. Moment of inertia, I is equal to mk square. K is the radius of gyration, m is the mass of the body, and this is a physical quantity which comes into existence only during the rotational motion of a body. So it is neither a vector nor a scalar, so this is a tensor. Some quantities, physical quantities which are neither vector nor scalar, they are called tensor. It can be written in the form of a matrix. Its components in different directions can be written in the form of a matrix, and we find the rank of that matrix. And a physical quantity, whether it is a vector or a scalar, it depends upon the rank of that matrix. So vector is having, or vector is a tensor of rank 1, and scalar is a tensor of rank 0. These things you should remember, as may be asked sometimes in the exam, and these were asked when I was when I appeared for the interview of the UPSC. I had twice cleared this exam. So in one of those interviews, these things were asked. So these are very simple things, you should know this, but generally the students, they go for only vector addition and parallelogram law and definition of vector. So these things you should remember always. What is a vector, what is a scalar, and what is a tensor. Vectors, they are also known as polar vectors. Why it is a polar vector? Because it starts from a point and it points in a particular direction. That's why it is called polar vector, or we simply call it a vector. Polar vector. This is a point, and we say that at this point I have applied a force, or I have applied a torque. Suppose this is a disk. It can rotate about this axis. What I do is I am winding a thread around it along the circumference and pulling the thread by applying a force tangentially to the rod. So I have applied this force at this point. If I see the axis about the center of the disk, which is at a distance r from here, what I am doing is, about this point I am applying a torque which is equal to the cross product of r and f, and it may rotate the body in this direction. So I am applying a torque. Torque is a vector which is r cross f. What is this cross? That we are going to discuss shortly. So this is a polar vector. Direction of this torque is cross product of r to f. So it will be perpendicular to both r and f in upward or downward direction, and you can use the right hand rule for this. If you move from r to f, so curl your fingers from r to f, thumb will point in the direction of torque. So torque is in this direction. This is the unit vector n in which the torque is acting. In this direction the torque is acting. So this is a polar vector. What is a pole? This point is a pole from which the tail of the vector is passing. How do we represent a vector? By an arrow in the direction. The arrow points in the direction of the vector. This is called head, this is called tail. If we fix this point, that is here, it is fixed, it is passing through the center, then it is called a pole, and this is called polar vector. We simply call it a vector. Now why do we call it a polar vector? Because we have other category of vectors, axial vector. This body is rotating. So the vector quantities related to the rotation, which are pointing always in the direction of this axis, they are called axial vectors. So we have polar vectors, which are simply called the vectors, and the physical quantities or the vectors, those associated with rotation about an axis, they are called the axial vectors. So this is the basic about the vectors. Now we can discuss further what is the component of vector, how many components are possible, how can we take the component of a vector. Now if I ask you a very simple question, what is the component of a vector? You all must be knowing the sine component and the cos component. So the next question is, how many components of a vector are possible? So the answer to this is, you can have infinite number of components of a vector. Suppose this is a vector. Head, tail of the vector, it is acting at this point. So this is the horizontal direction, and it is making an angle theta with this direction. I am taking this as horizontal, but it is not necessary. But for the purpose of reference, we take horizontal and vertical, x, y and z directions. We represent the vector by small case or capital letters with an arrow on it. So from this point is O. If I drop a perpendicular M, this point is say A, this is vector A, let this be a small case a. So it is perpendicular to this direction. So what I can write is here, the magnitude of this vector OA is equal to A, also written as sometimes modulus of A, one and the same thing. And vector OA is equal to A. A vector is always specified with respect to a fixed position, and that fixed position is called the origin. O is the origin here, so this is the vector. So if I drop a perpendicular from here in this direction, so I can write sine theta in this triangle. What is this? AM divided by OA. So this gives AM is equal to OA sine theta. What is OA? Magnitude of the vector A sine theta. And similarly, I can write OM equal to A cos theta. So a vector is having a component, sine component in this direction, means if I draw a line parallel to this, so this is the component cos component, this is the sine component. So a vector is having, we can resolve the vector into any number of components. Generally resolve in x, y and z, three components. In case of three-dimensional resolution of a vector, resolve into two components as shown here. Otherwise you can have any number of components of a vector in a direction. So A cos theta is called horizontal component of the vector. A is the magnitude of the vector, theta is the direction from this x-axis here. Theta, if you take theta here from the y-axis, this will be the cos component, this will be the sine component, and this A sine theta or this is called the sine component of the vector. So this is how we take the components of a vector. If a vector is having zero magnitude, then this is called null vector, written as 0. So if I change the direction of a vector, this is vector A, and I change the direction but magnitude remains same, then we write with a minus sign. This is minus A. If you multiply a vector with a scalar, like if you multiply this by 2, then direction of this remains same but magnitude becomes twice. If you multiply this by half, then direction remains same but magnitude becomes 1/2. This is how you multiply a vector with a scalar. This is very simple thing. Now as I told you, when we take the components of the vector, this is x-axis, this is y-axis. So if we have this point, say P, which is at a distance of say 10 kilometers from this point O, which is taken as origin, at an angle of 45 degree with the x-axis. You say that you are going from O to P, 10 kilometers in the direction northeast. So where is what is your exact position? So vector is 10 kilometers in this direction. So this is the displacement. If you move like this, that will be the distance. So here we have to show the displacement. So displacement is 10 kilometer northeast direction. If you take the components, you can take sine and cos components. This component will be, this is m, o, m. So this is, as I have discussed here, 10 cos 45. And this component in y direction, it is 10 sine 45 degree. So to represent a vector like this, we take a unit vector in this direction of x, because this is not in the form of a vector. So to convert into a vector in the direction of x, we multiply this by a unit vector I. I is unit magnitude of I is 1 and direction is along x-axis, and a unit vector j along the y-axis. Similarly, if I have the third axis, that is the z-axis, so along this direction we have the unit vector k. So I have resolved this vector into two components only. So I can write vector OP in the form of components is 10 cos 45 I plus 10 sine 45 j. So 10 by root 2 I plus j. This is how you can represent the components of a vector. If a vector is having component in third direction also, z direction, and how do we take that? Suppose this point P, and in space x, y and z axis. This is O, join this, so you get the vector OP. So it is making angles like alpha with x-axis, beta with y-axis, and gamma with z-axis. So you can write the components in the three directions. Suppose the components in three directions are x, y and z. So I will write OP is equal to xi plus yj plus zk. This is how we write the components of a vector in x, y and z directions. Now sometimes you come across the term equal vectors. What is equal vector? Two vectors A and B are said to be equal only if their magnitudes are same. Magnitude of A is equal to magnitude of B and directions are also same. Only then a vector can be classified as two vectors can be classified as equal vectors. So these are some of the basic terms of the vectors. Now we can add or we can subtract the vectors. This can be done graphically, or this can also be done by using the rules of addition of vectors. Now first of all, let us discuss the dot and the cross product of two vectors. First, let us discuss dot product. Suppose we have a vector A and a vector B, the magnitude of which are given, the directions are also given, and they are inclined at some angle with respect to each other. How to find the angle between two vectors? Suppose this is one vector, this is another vector, and this angle between two vectors suppose is 130 degree, A and B. So my question is, what is the angle between these two vectors? Sometimes the students say 130 degree, but this is not true. If you extend this vector in this direction, and this angle will be the angle between two vectors. This is 180, so 180 minus 130, 50 degree is the angle between two vectors. So angle between two vectors is the angle included when we join the tails of two vectors, head pointing in different directions. If two vectors are parallel like this or this, angle is 0 degree. Anti-parallel, angle is 180, and perpendicular, then angle is 90 degree. This is the angle between two vectors. Now I have told you how to take the component of two vectors, component of a vector in a given direction. So now we can discuss the product of two vectors, scalar product or vector product and vector product. So let us take two vectors A and B, point O, A, B. Angle between them is theta. The scalar product is defined as, because this is not having any direction, AB cos theta. A and B are the magnitudes of vector A and vector B respectively. Now from this point, drop a perpendicular on this vector. This point is M, 90 degree. So what is cos theta here? Cos theta is base OM upon A, magnitude OA. So OM, as I told you previously, this is OA cos theta, A cos theta. This is A magnitude, this is A cos theta. So A cos theta is A dot B divided by magnitude of B. What is this A cos theta? A dot B by B. This is the distance OM measured along this vector. So it is called projection of vector A on vector B at an angle theta with respect to the second vector. So if you send the ray of lights like this in direction perpendicular to this vector, one in the direction of O, other in the direction of M, or passing through this head of this arrow perpendicular to the base, then what will you see from the front? If from the top, if you see it from the top, what will you see? This line OA, the true length of this will not be visible to you. Only the inclined length of this will be visible to you, which will be in the form of a straight line. If a line is like this and you view it, you see the top view of this, what you will see is this line, which is not equal to the true length. So this OM is the visible length of OA from the top, and that is called the projection of A on B, also known as component of A in this direction. A cos theta, which is equal to A dot B by B. If you take component of B on A, in the same way I can write B cos theta is A dot B divided by A. These are called components. So A dot B is called the scalar product of two vectors. Suppose I have this body kept on the ground and I am applying a force on it F at an angle of theta with the ground. So it moves to another point and the displacement of the body is S. So we have the vertical component of force is F cos theta and horizontal is F sin theta in the direction of, F sin theta in the vertical direction, and in the direction of motion it is F cos theta. So which component is responsible for movement of the body? Obviously F cos theta, as component in the direction or opposite to gravity is not responsible for making the body to move horizontally. So what is the work done here? Work done is force in the direction of motion multiplied by displacement. So F S cos theta. So this is F dot S. So work is a scalar equal to the dot product of two vectors, force and displacement, F dot S. So we define work with the help of the scalar product of two vectors, and a dot b dot a are same. There is no change in the direction, magnitude is also same. That's why this is called a scalar product. If you take the two vectors, the vectors in the direction of x, y, z, I, j, k. Now this is also taken in accordance with the right hand rule. So if you move your fingers in the direction x to y like this, thumb will be pointing in the z directions. So I dot I is having magnitude equal to 1. 1 into 1 and cos of 0 degree equal to 1. Similarly, j dot j is 1, k dot k is 1. But I dot j, j dot k or k dot I, they will be having value equal to 0, as cos of 90 degree is 0. This is called the dot product of two vectors. Now next we have, now before this, let me explain this with an example to you. We have a question. The question is, a force is acting, F is the force is acting on the body, and that is given by, force is written in the component form. So 2, 3 and 4 are the components of the force in x, y and z direction Newton. If you have to find the magnitude of this force, that is equal to root of fx square plus fy square plus fz square. So here 2 square plus 3 square plus 4 square. Root 29 Newton is the magnitude, though it is not asked in the question, so I just explained it. So this force is acting on a body, and under this the effect of this force, the body is displaced from a point, this point, to this point, A to B. So these are vectors. The coordinates of A in space are 2, 3, 1 x, y, z coordinates, whereas B is having the coordinates of 1, 1, 1. So we have to find the work done. So W is obviously F dot S. F is given to us, we have to find S. What is S? This should also be in vector form, displacement. So let us take a fixed point O first, which is the origin. So as I told you, how do we define a vector? It is passing through this point. We take this as origin. Join this with this point A, the coordinate of which are given 0, 0, 0 are coordinates of this. So vector OA, suppose this is R1, we can write this as 2 minus 0 I plus 3 minus 0 j plus 1 minus 0 k, or simply 2i plus 3j plus k, and unit is meters. Whatever be the unit, I have taken this as meter. Similarly, join this with B, that is vector OB is R2. So OB is R2. I can directly write this as I plus j plus k meters. Now what is the displacement of the body? S. It moves from A to B, and this we find with the help of the triangle law that we will be discussing later on. So I am writing it here directly, that is equal to AB. So always write this as OB minus OA. Vector related to point B, or this point written here on the right side, minus vector related to this point A, or written on the left side. So OB minus OA, r2 minus r1. So simply subtract vector this from this. So here we have I, 2i. So this is minus I and minus 2j plus 0k. Subtract this from this, I minus 2i, j minus 3j, and k minus k. This is the displacement, mean meters. So what is the work done? F dot s. So 2i plus 3j plus 4k dot minus I minus 2j plus 0k. Now we have to find the dot product. So take the dot product of I with I, j with j, and k with k, and leave the rest. And unit is joule or Newton meter. So 2i dot minus I. So minus 2 I dot I, j and minus, so 3 into minus 2, minus 6 j dot j, and 4 into 0 k, k dot k. So this is 0. So we have minus 2 I dot I is 1, j dot j is 1. Minus 8 joule is the work done in moving it from A to B. It means that we are getting the work while moving the body from A to B. It can be explained like a body is kept at some height, it is moving in the downward direction along a slope, so we are getting the work. The potential energy of the body is consumed, the velocity is increasing. If you make it move in opposite direction, you will have to do the positive work. So this is called the scalar product of the vectors. Now we can discuss the cross product also. So we will be discussing later on the cross product of a body and what is a unit vector in a direction, that we will be discussing in the next discussion. This is all for today. Thank you.